This is part 3 of the review for the Chapter 5 test coming up on Friday, December 16th in 8th grade at Carroll Middle School. If you haven't watched the first two parts yet, I recommend that you flip back to those before you start watching this part. We're going to pick up at the concept of how a watershed works, and we're going to look at it in the case of the Eel River, which is very near to our school. The Eel River is one of the smaller streams, creeks, or even a small river that feeds into a larger river. The larger river it goes into is the Wabash River. That's just south of here. And it starts out actually kind of as a small river and then grows larger as it goes down towards southern Indiana. Now this river then goes into an even bigger river. An example of the bigger river would, in this case, would be the Ohio River. After it feeds into the Ohio River, it goes to an even bigger river, and this would be the Mississippi River. Now, the Mississippi River then empties into an even bigger body of water. In this case, it's the ocean, but it can even go into any other kind of large body of water, like we see with, say, the Maumee River, which is actually what the rest of Fort Wayne feeds into, and it's part of that watershed, which then doesn't go to the ocean, but it goes actually to Lake Erie, which is quite big as well. There are many ways that ponds can be formed. That's actually the next concept we're going to talk about. There's many different ways it can form. For example, a reservoir, which is just a man-made lake. Somebody built a wall to make the water so it stays in one position. Then we also have glacial lakes. That's actually what most of the lakes around northern Indiana are made from. Basically, glaciers dug holes in the ground. As they went through, they pushed the dirt forward, created a little bit of hills and the depressions, and then left some water behind. They started to form up, and then as rain came down, it filled up even more and formed the lakes we see today. There's rifts, which are actually formed from the valley around a river or a stream as it's carved down. And of course, volcanic lakes, which are formed in the crater or in the center of a volcano. Not something we see here around Fort Wayne, but it is found in some parts of the United States and in other parts of the world, especially when we go over towards the Pacific coast near the Ring of Fire. We see some more of these volcanic lakes form. Some general trends in the ocean. There's three really big general trends I want you to make sure you know for our test coming up. The biggest ones are salinity, and knowing that it varies at the surface. It can vary a little bit as you go down, but mostly it varies at the surface because we have evaporation, and when water evaporates, the salt stays behind. The next part is the temperature. As you move away from the equator, it goes down. That should be pretty obvious to you. I mean, we don't live very close to the equator, and it's a little bit colder here than, let's say, when you go down to Florida. It also goes down as you go deeper down in the water. It's not something we really can see, like diving down in a pool, but if you go into the ocean and dive down deeper and deeper, there's less sunlight getting down there. There's less surface heating getting down there, so it actually gets quite cold as you go down. Pressure also increases as you go deeper. That is something you can see a little bit when you go swimming at a pool. Let's say you jump off the diving board into the deep end of the pool. Your ears kind of start to close up a little bit, and you can feel that as the pressure is increasing. The next concept we need to take a look at is how currents work and the type of currents that we see. Now, the big focus we've been having is actually focusing on the North Atlantic, and I'll try to point to it here. You can hopefully see my mouse on the screen. The North Atlantic is where we focused a lot of time at. You can see the Coriolis effect going on here, and we see that the warm waters move away from the equator towards the poles, and we see the colder waters, or the colder currents, coming in from the poles and pushing down towards the equator. That's a very common pattern. We can also see it here again in the Pacific Ocean, both the northern and the southern Pacific. It's also important to note here that you can see the Coriolis effect is actually in opposite directions on both sides. Now, we also need to think about the concept of the El Nino and the La Nina and how they affect our climate. As I already said, El Nino is caused by warmer water moving towards South America. It stops actually colder waters from reaching the surface, and it causes an unusual or severe conditions. For example, we've seen more tornadoes and greater snowfalls from the El Nino. The La Nina is when the surface waters are actually much colder. It gives us a little bit colder winters, which makes sense because it's colder water. It means you get colder air above it. It means you're going to have colder winters. Then also, there's also usually a little bit more precipitation in the north-central United States and the Pacific Northwest. It's kind of interesting. It affects the north-central, and we're really not that close to the ocean. The next part is taking a look at the topographic maps, and unfortunately that's going to need to be in part 4, so join me there.